The population of elephants in an African national park is given by A equals 6,000 e to the 0.05 t, where t is the number of years since 2000. What was the population in 2000? That is just 6,000, because that is the initial condition. What is the growth rate of the population? That is 0.05 or 5%, which we just take from right there. How long does it take for the population to double? So double 6,000, that would be 12,000 equals 6,000 e to the 0.05 t. But really, you don't even have to put the 12,000. If you ignore the initial condition, what you're basically asking when you ask for doubling rate is, when does this thing, e to the 0.05 t, equal 12,000 divided by 6,000 is 2. Take the natural log of both sides, or you can also look at it as change form. So ln e to the 0.05 t equals 2, and that gives us t equals the natural log of 2 divided by 0.05. Put that in your handy dandy. And we get that t equals 13.86. Since t is the number of years since 2000, that's going to be 2014. In 2011, earthquake and tsunami caused release of 10 million gallons of radioactive iodine-131 into the ocean. The half-life of iodine-131 is 8 days. Not until fewer than 100 gallons of iodine-131 remain in the ocean will it be considered to be safe for humans. Write a function to model this situation. All right, so what do we know? We know that we have an initial condition. All right, this is one of those A equals PE to the RT. We know that our P is 10 million. The half-life is 8 days. And we'll talk about how to use half-life in just not until fewer than 100 gallons remain will it be considered safe. So the question is, right, when will A be less than 100? We'll get to that. Let's make our formula first. So what we've got defined first, we've already got the P. We need to figure out what the R is. Now, it's a half-life problem. It's a decay problem. When that term half-life, that shows that things are getting smaller. So in 8 days, we have half of what we had right now. So what that means is E to the R times 8 equals 1/2, whatever that R is. Let's make that 8R. Because after 8 days, we have half of whatever we started with. After 8 days, we have half of whatever we started with. So now what we've got to do is figure out what that R value is. What is the rate? So we take the natural log of both sides, or you change your form. The natural log of 1/2 equals 8R. So R equals the natural log of 1/2 divided by 8. Putting that in my calculator, natural log 0.5 divided by 8, we get that R is negative 0.086. So going up to here, we now know that our formula, A equals 10 million times e to the negative 0.086 t. There's the formula. The question is, when will it be safe for humans? Well, it says 100 gallons are left. So when A is 100, so 100 equals 10 million e to the negative 0.086 t. Just make sure that you're keeping track of your zeros. So we divide both sides by 10 million. 100 divided by 10 million. And when you put this in your calculator, 100 divided by 10, 1, 2, 3, 1, 2, 3, you're going to get 1e negative 5. This is the way the calculator writes 10 to the negative 5th power. Right? So all this means is t is 10 to the negative 5th equals e to the negative 0.086 t. We change our form, this time using the natural logarithm, we get that 0.086 negative 0.086 t equals the natural log of 10 to the negative 5th power. So t equals the natural log of 10 to the negative 5th divided by negative 0.086. Plug that into the calculator. Natural log 10 to the negative 5. Divided by negative 0.086. T equals 133.87 days.